The WTC32ND-14 is a mini instrument temperature controller with a temperature display and onboard adjustments. Wrapped around the precision WTC32ND temperature controller, it is configured for use with the TCS 610 10 kΩ thermistor and various thermoelectrics, driving up to plus or minus 2.2 amps. The controller is particularly suited to applications where temperature is scanned across ambient, such as electro-optical systems, LiDAR, Raman spectroscopy, and medical diagnostic equipment. Always observe ESD precautions when handling the WTC14 and thermoelectric. For more information on ESD, see the application note on our website. Before attempting to run the controller, determine if it will operate within the SOA or safe operating area. Our website also has a video tutorial on using the online SOA calculation tool. We will use the following equipment to configure the WTC for 0.5 amp operation using a 7-volt power supply, a 10 kΩ thermistor, and a thermoelectric. To configure the mini instrument, we will need to use the control components shown. Install a jumper indicating which power supply you have selected, in this case 7 volts. Next, to protect the thermoelectric from overcurrent damage, we will set the current limits to 0.5 amps. The standard product is shipped with 2.0 kΩ resistors already installed for 0.5 amp cooling and heating limits. For greater output power, the resistors need to be changed. If you need to do this, be sure to verify your values with the SOA calculator. Resistor A sets the cooling limit, while resistor B sets the heating limit. Resistors should be 5% metal film and size 1206. Carbon resistors will introduce noise and instabilities. Now we will set the proportional gain and integrator time constant resistors. The default 10.09 kΩ resistor provides a proportional gain of 20, suitable for a thermistor with a fast responding load. The default 31.6 kΩ resistor provides an integrator time constant of 1.5, which is also appropriate for our load. For more information on optimizing control, refer to the tech note on optimizing thermoelectric control systems on our website. Wire the output connector as shown. Connect the thermoelectric wires to the red and black cable wires. If the polarity is reversed, the system will only heat. Connect the thermistor wires to the green and white cable wires. Polarity is not important. Plug in the power supply. Note, when you plug in the supply, make sure the enable switch is off. Do not operate with a voltage less than 7 volts. To set the set point temperature, put the switch to set. When the set point is displayed, the rightmost decimal point is lit. The controller's resistance to temperature conversion software assumes the thermistor bias current is 100 microamps, and the thermistor is characterized by the following Steinhardt-Hart relationship. To use another sensor or change the calibration, contact the factory. The set point temperature can be adjusted from 10 to 65 degrees C either by using the onboard 12-turn potentiometer or an external voltage source. The VSET wire pads can be used as test points to monitor the potentiometer setting or for connecting an external voltage source, such as a function generator. If an external voltage source is used, set the set point potentiometer approximately mid-range 1 to 1.5 volts. The input range is 0 to 2.5 volts, which corresponds to 0 to 25 kiloohms of thermistor resistance. Change the switch position to ACT to monitor the actual temperature. Switch the enable switch to on and monitor in-range status. If the actual temperature is below the set point temperature, the lower LED on the in-range indicator will light. If it exceeds the set point, the upper LED will light. The green LED is lit when the actual temperature is within 0.05 degrees C of the set point. That's it. Now you are ready to control your load. There's more technical information in the datasheet, which can be found on our website, along with app notes, tech notes, and FAQs. Our goal is to help you succeed. If you have any questions, contact our technical support engineers. Consider us an extension of your team.